Review number 2 for the linear geometry. I'm going to look at numbers 1, 2, and 4 in this video. Number 1 is dealing with quadrilaterals, and I'm going to zoom in just a little bit. Quadrilateral PQRS has perpendicular diagonals PR and QS. The quadrilateral must be blank. And I changed that to must because it'll change up the answer a little bit, and that's more what you're going to see like on the test. So we look at the 4 choices: square, rhombus, parallelogram, rectangle. First of all, you obviously have to know what the diagonals are and what perpendicular means. So if I just draw a random parallelogram, remember that the diagonals go from one corner to the opposite corner. There's one diagonal and there's a second. Now it says perpendicular. Remember, perpendicular means that these have to meet at right angles. Remember, this is your symbol for perpendicular, so we have a right angle happening. These two do not meet at a right angle. You have an obtuse angle there, you have an acute angle right there. So it can't be parallelogram. Now if we look at the rectangle, any old rectangle, same idea, we're drawing the diagonals. And same thing happens. This is still obtuse, this is still acute, we're still not getting the right angle. Now when you get to the rhombus, and notice the order I'm going in, remember rhombus is like your diamond shape. So if I go on the side here and draw a rhombus, there's my diagonals. You do get a right angle on those diagonals. That is one of the properties for the rhombus. So rhombus does work. And remember, whatever the rhombus has, the square also has. So if I draw the square, there's my right angles in the corners. And this is not the most perfect drawing, but you do get right angles in the middle for the square. So square and rhombus would both be appropriate answers for number 1. Number 2, use triangle FCD to find all the variables and the measure of angle F, and I added this part: if AB is the midsegment of triangle FCD. Now that we know that AB is the midsegment, that means that these two sections are equal, those two segment lengths are equal. It means these two are equal, which means that for Y and for X, those become simple little equations. Since these parts are now equal, I can set 5y equal to y. I can divide and I get y equals 1. And the same idea for x, I can start with 9 equals 3x. I can divide there and I get 3 for x. The only slightly more difficult part is the z. On there you have 5z minus 2 on the midsegment and 13z plus 13 on the base. And remember, for the midsegment, the pattern is that you take whatever the midsegment is and you double it. There's 2 of these midsegments in this base on the bottom. Plus 13. Distribute the 2. I get 10z minus 4. 13. Oh, z plus 13. Subtract 10z from 13z. I get 3z. Subtract 13 from negative 4. I get negative 17, which means my z is negative 17 over 3. Not always going to get a negative there, but that is a possible answer. Number 4 is the third one we're doing in this video. We're given that line P is parallel to line Q, and both these lines are intersected by transversal T, and we're asked to solve for x. So we look at where 3x plus 75 degrees is right here, x plus 5 degrees right here. And if you're going with the formal names for all these angles, excuse me, remember that both these angles are interior because they're inside these parallel lines. They're on the same side of the transversal. They're both on the right side of this line. So these are same side interior, or sometimes they were called consecutive interior. And if you remember those names, maybe you remember that these are going to be supplementary. They add up to 180. Now, if you don't remember the names, remember that you have one acute angle here. You have one obtuse angle here. When you have the parallel lines with the transversal, anytime you get one acute and one obtuse, you will be able to use the 180. Whenever you have one of each kind, you can use, they will be supplementary. X plus 5 plus 3x plus 75 equals 180. Combining the like terms, 4x plus 5 plus 75 is 80. Subtract the 80, you get 100. Divide by 4 and you get 25. There is number 4.